We will start with an overview of the EDITO platform, and then we will go through some practical use case demonstration of users that beta users that have tested the platform, and then we will have time for your questions and for discussing together. So I give the floor to my colleagues, Quentin Godel and Chloé, so that they can crack on with the overview of the EDITO platform.
Thank you, Marina. So yes, so we have 15 minutes to explain you what is the benefit.
Quentin, you're muted.
Okay. Can you cut yourself? Thank you. Can you hear me well? Okay, thanks. So thank you, Marina. I will deep dive quickly into an introduction of the platform. Can you switch from the slide, please? Thank you. Then I will explain you the challenges we face and how we decided to tackle it through some design criteria and architectures. And finally, I will try to give you a brief demonstration of the platform. Can you? Thank you. So the idea of the EDITO infra project was to build a platform, which is called EDITO, that is backbone for a lot of projects to exploit near data, benefit from a simple integration with external services, other European services, and to propose to the user some cloud resource capabilities such as data storage and also engine. So we try to have a somehow a backbone for everything there. So what we built so far is in between an end user services and a cloud provider, basically speaking. So I will try to demonstrate that. So the main challenge of the digital twins is to be able to run what-if scenarios. And what are what-if scenarios? So they are available through some web APIs that have been developed by someone and web UI, sorry, and that they allow to generate data that have never been generated before. So basically, an end user should go to a platform, discover around what are the capabilities and try to figure out what he wants to discover, to create. And then he runs the scenario, it produces some new data, and then he have the answer he was asking for. So basically, we have three components there: the digital twins, something that is a concept so far, end user web services, and what if scenarios. And to be able to run that, can you switch to the other slide, please? Then you have the need for computation function, and function requests some inputs and provide some output data. So we have to put this in place, of course. And then, can you switch the slide, please? What we want mostly what we want to avoid is to generate some non-qualified data. We want somehow that data and process are qualified, controlled by the community of oceanographers that we represent. And finally, to help the user, the scientist, the developer and the scientist to do that, can you switch to the other slide, please? They need some tools to check the data, to build the end user applications that will propose what if scenario as a service. And they need also tools to build the function. And that is where what we built so far, what we analyze. Can you switch to the other slide, please? 3 layers of API: a service API for toolings and what if application, a process API for computational function as a service, and a data API. And all the 3 API, of course, will have web UI built on top of it to ease different personas of user and user like policymaker and citizens, but also some advanced UI for advanced user contributors of the process, the services, and etc. And we also meant at integrating with external resources such as HPC, external projects such as the Copernicus Marine project, the MONET project, and everything. And so far we run on Wikio, and soon we will migrate to the Destination Earth platform and integrate with their capabilities as well. Can you switch? Thank you. So in comparison to current existing marine data portal, what we aim to tackle is, and to propose mostly, is near data computing and to promote data subset. So that is to ease the transfer delay you can have when you are building and manipulating oceanographic data. We want to facilitate the cloud resource access, also the GPUs exploitation, and the HPCs, as I said. By that, we meant that automating the plumbery to integrate all these components all together. We want to promote the reuse and the reproducibility of the work that is done as part of the digital ocean. So the FAIR principle, of course, but basic scientific approach. And we want to have a platform that is open and collaborative, so that you don't need a heavy user support to access and to do stuff on the platform. And we want a platform that is highly available with the minimum of interruption of services. And we meant also at minimizing the cost of everything. So going back to the three layers of APIs, the data API, the process API, and the service API, well, basically what you can do on the platform, and we will see that together, you can discover all the services that already exist on the platform that you can launch, you can share with your teammate, and so on. You can also discover there some ocean-specific services, because there is some tools services such as IDE or databases, but there is also some ocean-specific services that embed your common tools of the ocean and so on. The process APIs, it aims at referencing all the function, whatever the implementation. If you are doing some Fortran or some Python, we don't really care. We use and we promote the use of containers to do an abstraction over it. But what you can do and what function means is mostly like ocean models, post and pre-treatment. And what we really want to do is to promote the remote launch of on-demand processing, meaning that someone can trigger a job. It does not mean that it is better to run it somewhere or somewhere else. This kind of stuff can be done with the process API. And finally, the data API, well, we meant at referencing all the assets. So first, it's a kind of main catalog for referencing a lot of data sets that make sense for this platform. You can reference in there assets that are stored somewhere else, but you can also upload the data to the data lake and then automatically reference them into the data API. Can we switch, please? Thank you. So, of course, we set up in place an identity and access management platform. And thanks to a combination with secret management, basically what you can do is you can trigger some jobs that are running on external resources, such as HPCs. If you have account on Euro HPC, you can do that. And finally, you can switch. We aimed at promoting standards and mostly only standards, meaning that we respect the Open Geospatial Consortium as much as possible. We respect also the Open Container Initiative. And also we promote the use of scientific convention for the data itself. So basically today you have a platform that is running since September 2024. And this platform has a home page, and from there you can access a tutorial platform, a data lab, and a viewer. So we're gonna dive right now into the tutorials and the data lab. If I can take over the screen, and I cannot. Is it possible? No, I cannot share my screen.
Well, you should be able to do that, Quentin, now. Try again.
Okay, I hope you can see my screen now. Okay, so this is a homepage, dive.edito.eu. You have some explanation about what are the three main web components there is. As I said, there is a component to discover a lot of resources about ocean. So ocean modelings, also the documentation of the platform by itself. If you want to do something, you can start there to have a quick search. What is nice also in this tutorial platform is that you can read some stuff, but you can also run some stuff, and it will directly dispatch you into the other component, which is the data lab platform. So I will come back to that later. If we go to the data lab, there you can discover here a catalog of services. So you have like plenty of services that maybe does not ring a bell to you, but some are popular, some are created by the users actually. You have some ocean modeling services, such as some demonstration for Nemo. You have some embedding of AutoSummit, tools to dispatch job on HPC. You have also some Jupyter's labs that embed directly some ocean tools. You can also find more common IDE or databases or automation, and you can launch everything there once you are connected to the platform. And then it will run on your name. So I will try one, for example. For example, this one. When I launch it, I have the possibility to configure some stuff there. So I won't go deep dive into everything. So I won't dive it right now into that. But then it launch it. So it tells me some information about what are the embedded services that are already available. So these are some familiar tools of mine. The service is started, and then once it is started, I can access it to a public URL. And I can see in the My Service tab, I can see here the service that is running. I can discover how much resources takes for me, because I have some quotas there, so I can start other services if I want. I can also save some configuration for the services. I can pause the services if I wish. Here I can easily access the services which is protected with the password that I own and I can manage in my data lab. And then I access the data lab instance. And here I can do everything I want to do with data lab and with the Jupyter lab, and you can do the same. So basically you can do this with all the services that are available. You can also add services to this catalog to share them with your community and your colleagues. And you have the same for the processes. For the processes, you have other process that are there, adding by the scientists at Mercator, added by some other scientists that decided to propose this computation to anyone. In your account, you can discover that you can link with other services accounts, such as, for example, GitHub or GitLab. You can share your token. You can also connect to external S3 storage. You can also configure your vault. So Vault is something that allow you to manage your secrets, or you can create some secrets there, and then it will be, you can say to embed them in your services, so that you don't have to do that by hand. You don't have to go bypass secrets. That means passwords, tokens, credentials, this kind of stuff. It's secure. If you can do it in a secure way if you wish through the platform. You have the possibility to browse your files as well. You have a storage, a personal storage. You can upload files there. You can create directory. It's the S3 backends. And once you launch a processes, by default, it will put the output of the process there in the file. And hence, in the end, you can browse directly the data in the Data Explorer if the format is compatible, because it does not support everything. So here, for example, there were a process that generate a Parquet file, and I open it, and I can browse it directly there. You can also work in group. So for example, here is my personal project, but I can switch to another group. Let's say this one. And when I'm there, I can see that, okay, so there is another Jupyter there, but I could have other services running there in the name. What you can see here also when I launch the Jupyter is that there is a public URL here, which is under my username. And for some services, if it makes sense, you can fix this namespace. So for example, it's easier for you if you want to communicate to the service to someone else. For example, I don't know, you want to run I don't know, a Postgres instance. You can say postgres.lab.dive.edito.eu, and it's easier than this ugly prefix there. What else? I think got it right back. So when you go, if we go back to the tutorials, you can, for example, discover. First, you can discover how to contribute, so how to add data, how to have services and processes to the platform. And if you go to some tutorial has the run button, and if I click there, then it's dispatched automatically to the data lab with the service to run, and it will run automatically the service for everyone. So in a single button, you can really communicate to other people what you have built and how to launch it, and so on. So I think that is all for me. We'll give the floor to my colleagues, Chloe.
So hello everyone. If maybe Peter, yeah, thank you. So now, yes, I will just be introducing this practical use case, demonstration, and practical applications. If you can switch, please, Peter. And as Quentin has demonstrated just now of the platform, so this platform, we had a little misunderstanding in our slides. Sorry, so the beta opening was the first one done in September 2023 because it is past. And what allowed this to do from our side is to allow interaction on with end users on their needs, to have support to contributors of services, processes, data, tutorials to exchange, and with these exchanges to be able to keep the development of the platform with additional features and tutorials. And it's really very, very interesting for us to have all these contributions and exchanges. So thanks to all of the people who participated in that. And this was like some really close people like the EDITO Model Lab, and also some specific people that were interested and that allowed us to add elements to this platform. And what we will be demonstrating now and presented is a use case, is the user experience of several people, which are Felix Dals, Matteo Mikos, and Connor Delaney, which agreed to present you how they did use this platform until now and what they could do with it. So I will first give the floor to Felix Dulz to present his use of this platform.
Thank you, Chloe, for giving me the chance to present, and also thank you for all the help in using the platform so far.
I'm sorry,
Felix.
I think we can't hear you, maybe, or is it just me?
I unmuted myself.
We can hear, yes, we can hear you, Felix.
Hopefully it's just Chloe's sound. I'm Felix Dulz, representing the EDITO Model Lab team, and I work for Deltaris, but together with 13 partners, of which 6 other partners are modeling. We contribute processes and services to the platform. Can we go to the next slide, please? We contribute what-if scenarios and focus applications. What-if scenarios are more directed at end users, so policymakers, and we contribute end-to-end services on 3 different topics. One is on nature-based solutions for coastal erosions, and simulation of tens of thousands of scenarios. You should be able to answer the question, what if we reconstruct seagrass to absorb wave energy, and this will have impact on coastal erosion and flooding. So this is mainly done by our partner Harion from the Helmholtz Institute. Then there's also a what-if scenario on marine plastics for zero pollution, where we want to answer the question, what if we capture plastics before they reach our seas? And for the Baltic Sea, there is modeling of circulation and drift of these plastics, and also sinking of macro and microplastics. And scenarios can be run in seeing the effects of measures of limiting pollution from riverine inputs to coastal areas. The third what-if scenario focuses on aquaculture for zero carbon, where we want to answer the question, what if we implement large-scale aquaculture, shellfish in offshore wind parks, where we're modeling the impact of these aquacultural sites on the carbon cycle. And can we go to the next slide, please? There's also focus applications, which are more meant for interactivity, for intermediate users who can use components of the workflows or of these applications to do their own research. And they're focused on 3 areas again. The first one is on marine protected areas for biodiversity, where we want to map the suitability of an area in a range from 1 to 0 of habitat species, like, for example, shellfish that offer food, or seagrass that offer shelter. Then a second focus application area is ship routing optimization for zero carbon, where we're using ocean forecasting of waves and currents for optimizing the route from specific starting points or on-demand specific locations of ships, optimizing the routes for least emission necessary to complete the route. And a third focus application is on oil spill modeling for zero pollution, and where we simulate the release of oil from ships. We can go to the next slide, please. We will zoom in on one of our focus applications on biodiversity for marine protected areas, where the goal was to model the suitability of crucial habitat species. So again, either, for example, shellfish or seagrasses, but this can also be mangroves or different species in different areas. And we do this by applying knowledge rules to every cell of a 2D or 3D environmental data set. And as multiple factors can influence the suitability of an area, we combine multiple of these rules, and they can be applied to a combination of data sets. And this results in a map, like shown here on the right. This is only for applying one rule to one spatial data, but you can combine that and overlay that to a final map. Let's go to the next slide, please. For this purpose, we want to explain a little bit how this was deployed on the EDITO platform. So from left to right, we go from pre-processing to simulation to post-processing and analysis. And then the components all have an orange arrow, that is the input, and a brown arrow, that is the output of that service or process. The first service is a model builder. So that's basically Jupyter Notebook environment where data is downloaded from the data lake, and with user inputs, a model is created, or a setup of a model to be run in a hydrodynamic process. And then a second pre-processing is to set up. Every time I get a message, it's in front of my slides. The second pre-processing is to define the knowledge rules that we will apply to our spatial data. Then the simulation is a process that is already published on the EDITO platform, so usable for everyone. And it's DOF2024 in a Docker container that uses inputs from the personal cloud storage, this my files or S3 buckets that Quentin showed before. And it results, or it computes spatial environmental data in that CDF format. Then when you use a different produce non-UGrid formats, subsetting is needed, but as we're producing UGrid formats with DOF2024, we don't need that post-processing step. And for analysis, we use the equal impact. So we apply the knowledge rules for the correlation between physical environmental data and the habitat suitability. So we use inputs from the cloud storage that was simulated by DOF2024, and we upload this spatial habitat suitability maps in that CDF formats. If we continue. Here we show the first service, so setting up a model. We deployed the Jupyter Notebook service, and now we initialize to our GitHub environment, and we call for the credentials. This will be automated when we publish this service. Now this was run on a personal node. So as Quentin also did, you get your personal token. Then a Jupyter Notebook environment is launched. This will be optimized in a Docker container for initialization. And here the user gets interaction in defining the spatial domain and the temporal domain for a model to be run. And now we run the whole notebook at once. But this can be done in blocks so that the user can learn how this works. On the left, you see that the model is simulated, and here you see all the different data that is loaded and that the user can visualize to interact with. The model setup that is created is now here in this Jupyter Notebook environment, but we want to upload that to the cloud storage, this S3 bucket, and this also will be automated, but is not yet. So one line of code was needed, but here we see that in the my files, the model setup to run DOF2024 is, I will close the message, is now created. And we can go to the next slide, please. And so we start with the same model setup. And in this model, there's also a shell file to run a Docker container. And if we now open the DOF2024 process that is already published on the platform, also we will improve the interaction here, but This was to show that we can make a computation on the platform. So it's now without any interaction, so a bit of a black box, but in the surface you create the model, and it is explained where to get your data from and how it works. Then the model is created automatically. DOF3D was, the process was called for and executed on the platform and creates output. So here you see a netcdf file with the spatial data and also a history file with data at locations, and a dialog file which gives information about the computation. We can go to the next slide, please. We're doing this because as an institute, we see added value in publishing our workflows of data and computing services on the EDITO platform. We see that there's better accessibility, so there's an ease of use and also speed of use that is not there when we have to distribute executables to do that. So no installation is required for external users. There's better compatibility, so we're also, for example, DECO Impact, the post-processing, also works with other hydrodynamic simulation software like Nemo, for example. And we're working on efficient access to public data. So this model builder and that opens the data directly from the data lake instead of downloading full and bigger data files. Then the last added value for us is that we can use this and have already used this platform for training external users, where again, we don't have to distribute any installation executables, and we can just direct them to the platform and new users can start working with it, which is very convenient for us. That was a bit of our experience, so I'll give the word and the floor back to you, Chloe.
Thank you very much. I will now let Matteo, Mikos, and Conor Delane to present their own use of this platform. And thank you very much, Felix, for this presentation. We hope it will keep being very useful to you.
Good afternoon, everyone. Thank you very much, Chloe, for the introduction. Indeed, I currently work at EMODNet, and I'm here on behalf of the EDITO Infra team to present my experience using the EDITO Data Lab services and run you through some of the tests I did. In particular, we'll look at how I adapted tutorials on the use of EMODNet web services to publish and run them on the EDITO platform, visualized raster and vector data sets in different formats, and played around with the data sets as well, and utilized the computing power of EDITO to access large amounts of data relatively seamlessly. Next slide, please. Yeah, first a little bit of information about my background. I come from a master's in marine sciences from Utrecht University, during which I focused in part on marine geochemistry and environmental modeling, but mostly on the analysis and visualization of marine data using Python and Jupyter notebooks. I then carried on a complementary master's in Amsterdam, during which I took an interest to couple land and sea management practices and the processing of GIS data for environmental analysis using open source GIS softwares. Next slide, please. I had prepared a slide on how I created the EDITO services to run Jupyter notebooks, but this has largely been explained by Quentin, so I think we can brush over it pretty fast. When creating EDITO services, you can specify different resources you need in terms of random access memories, CPUs, and as shown, there is an interactive dashboard that allows you to keep track of the different resources you are using across your services, as well as, and then since those services are ephemeral, you store data on your data outputs on S3 buckets accessible through the EDITO platform as well. At the moment, I'm using default settings with 32 gigabytes of RAM and 8 CPUs, which will come important when looking at the speed of calculations we can do. Next slide, please. So at first, I got introduced to the EDITO platform and EDITO services through web service tutorials that I had made on my personal laptop. These tutorials were divided into 4 parts, explaining how to access data through web mapping services for visualizing simple maps, or web coverage and feature services for accessing vector and raster datasets, as well as web map tiling services for accessing pre-rendered georeferenced tiled maps, mainly for online interactive visualizations. Next slide, please. So once that was done, which, by the way, those tutorials will be available soon in the tutorials tab of the EDITO platform. I went on trying to visualize different data sets and data formats through Jupyter notebooks. Some of those are the bathymetry raster from the EMONET catalog as a netcdf file, and the wind farm project shapefile from EMONET human activities as a JSON file. And in order to create the visualization that you see here, I had to do some basic geoprocessing computations, such as reprojecting the shapefiles to the correct CRS and some other stuff. And throughout my whole work, I stored the data sets and the outputs of my work in S3 buckets in order to access them fast. Next slide, please. Finally, as here it gets a bit more interesting, I tried to utilize the computing power of EDITO to access relatively large files. This is a bathymetric data set stored in a cloud-optimized format, in a ZAR format, that is accessible already on the EDITO data lake. The full data set is about 66 gigabytes, and I'm accessing one of the variables stored, which is the elevation variable, is about 22 gigabytes in total. Now, I was able to access it using Dask, which is a software library that enables parallel processing in Python, and with which the dataset is chunked in more manageable pieces. As you can see, the whole array is about 20 gigabytes and is chunked in 120 megabytes chunk, which are then processed in parallel using all the CPUs that EDITO allows to use. And the results of being next slide, please. Sorry. The results of being able to use this computing power is that I was able to visualize the bathymetry across six different regions. And it's important to remember that the amount of data and just the rendering speed of the visualization scale with the region size. And for example, the bathymetry of the North Sea, which you saw earlier, was about 360 megabytes, and it renders much faster than the one of the Mediterranean Sea, which you can see here, which is about 3 gigabytes of data. Overall, visualizing 6 regions at the same time is a total of 4.5, not 15 gigabytes of data. And when I ran this Jupyter notebook on my personal computer, it took me about 11 minutes for the visualizations to render and or for the data to be accessed and then the visualization to be to render. When running this on EDITO, I scaled down the timing it takes to about 1 minute 20. Now there is some differences depending on what other processes are running on your computer, but on average it was about 1 minute 20, so much faster to run these Jupyter notebooks on EDITO. Next slide, please. Now looking forward, I want to create tutorials which will be made available on EDITO for setting up services and use and access EMODnet data that is already present in the EDITO data lake. And I'm looking to complexify my analysis by accessing even larger data sets. And why not test the capabilities of EDITO for processing satellite imagery or Copernicus marine data, similarly to what we can currently do on open source GIS programs, but utilizing the high performance made available by EDITO. Thank you very much. This is it for me.
Thank you very much. Thank you very much for your sharing, Matteo. And I will leave the floor to Connor Delaney for the question and answer of the session.
Hello, can you hear me okay?
Yes, we can hear
Yeah,
you.
good. Thanks, Chloe. Thank you all for being here today. We saw two great use cases, one from Felix, where he was using EDITO to do high performance modeling, and then one from Matteo, where he was using EDITO to visualize big data. And this is one of the things that we're trying to achieve with EDITO, is that we have a mixture of types of users on the whole system, so that people producing products from modeling can make their outputs available to people who want to use those products to get insights on environmental challenges in the marine environment. So I'm just here for the question and answer session. If you have any questions, please raise your hands. I just see quickly in the chat that a question came from Thomas Sellur, who's at the JRC, I think, about if the Deltares automatic model launcher is available on GitHub, and I see Felix has already answered that in the chat, that the model builder is part of the Deltares DFM tools, and that they are up on GitHub. You can see in the chat if you want to see it yourself. So if you go to GitHub Deltares DFM tools, you'll see the model builder. So any other questions there? I'm not seeing any myself. What is meant by QGIS API on EDITO? Okay. Oh, sorry about that, guys. Matteo, can you explain there what you were talking about, QGIS API on EDITO?
Yes, thank you for your question. So the idea is that QGIS is an open source GIS analysis program that is built on a series of libraries, among which some Python libraries such as GDAL, and these libraries could be accessible through the IDEs that are made available as services on EDITO. And my idea, which is really an idea at the moment, but would be to develop something similar to the local program that is QGIS, but hosted directly as a service on EDITO. I hope this answers your question.
I see that Marina has put in a link to the Data Lab Dive. So you can look in there. I know from that there's libraries for GTAL are already available in some of the Python notebooks. I think when we were chatting about this before, Matteo, we were just daydreaming about the idea of being able to launch a desktop QGIS or a desktop Snap toolbox on a high performance computer. And we were wondering if this could be possible through EDITO, and we're thinking about looking into it in the future. So we're just speculating ourselves.
So Connor, we have some additional questions in the Q&A.
Yes.
Okay.
So with Data Lake, the core of Quentin could dive in here as well in a few minutes, but the core of EDITO is high-speed storage facility based on S3, which is simple storage solution, as an open source deployment of that. And the in a data lake, data is stored in many different formats in a reasonably ad hoc way, along with metadata. So the idea being that you store the data as loosely as possible or closely as possible to its published format, and then others can transform it using the low-cost compute that's been made available into the formats they need. So that's what we mean by data lake. So we're moving over into the data lake, or copying over into the data lake. From eModNet, we have very little big data. It's like our bathymetric data is big, but we have lots of varied data in many different formats. And we're making copies of all these in the EDITO data lake so that people can access them and process them and use them in collaboration with the Copernicus Marine big data. I don't know, colleagues in Mercator, do you want to add to that?
Yeah, thank you, Connor, for the explanation. Maybe I can add that so it actually depends on the need and underneath, but it's the data lake is not real, like a real data lake, like as you can find in the definition in over the internet. It's composed of a data catalog and a data storage. So data storage has been described by Connor. There is public bucket and private buckets as well. In the data lab, you work with your private buckets, but you can still share data publicly from there. And there is also the public buckets that are today used by the EMONET community mostly, but later it will be available for other people as well. For the Copernicus Marine side, there is no need of hosting the Copernicus Marine data into the EDITO data lake, because the data are already available as analysis ready and cloud optimized formats, meaning that as part of EDITO, we just reference the data of Copernicus Marine there. And you can do the same. If you have your data already stored somewhere, you can just add the metadata to the data catalog. It will be somehow part of the data lake of EDITO. But if you don't have the resources, or where it is hosted, it does not fit the capabilities and the performance you need for accessing the data, or allow the access to the data, then you can copy them and embed them. That's what the EMONET community did. Copying the data and transforming the data to Arco-native directly in the data lake of EDITO. I hope it is clear.
There's a question here for Quentin, actually for you, from Pedro Montero from Galicia, about the end of the project. Will he be able to upload his own model and run it on the infrastructure?
Well, so this particular project will end in September, and it is about having a pre-operational platform. Then it will continue with another project for the operational states of it. So if you call model some computation, then yes, you can directly do that and you can generate the data there. If you call model data, well, you can still do that, but today you have some restriction of quotas, and it will depend on if we can bump your quotas so that it fits the actual need for your need. I mean, for your project. Is it clear, Pedro?
And there's a question here from Mario Salinas. Is it possible to generate data and upload them into a shared bucket in a way that every EDITO user could then access those data? And I say yes, with qualifications.
Yeah.
Go on.
Sorry, Connor. But you can share that with people that does not have an EDITO account, because you are the owner of the shared bucket of your bucket, so you can share a part of your bucket and it will be accessible publicly to anyone. So you can actually build some stuff in your private and in privacy, you can say.
Yeah, so the S3 buckets are essentially just what we say. They're S3 buckets. So you put your data in a bucket and you make that bucket available to the public. Then you're sharing that data. So that's the basis of EDITO. I'm not seeing any more questions. Am I missing anything here, Angeliki?
Yes, there is a question. If we can share some details about the upcoming technical workshop in Brussels. I leave the floor to you.
Is it the DigitalOcean Forum? Yes. Can we come back to that in a moment and just see that Arne's asked a question about getting access to EDITO. Did you see that one? And Bente's asked that one too.
Yes. And whether it's open to users now.
So Marina, do you want to step in on that one? Because I don't want to preempt you on this.
Marina, can you hear us, or Quentin?
Yeah. Sorry. So yeah.
Yeah. So we can share a few slides for.
I just want to say, when I want to preempt you, there's going to be an announcement at the DOF on this.
Sorry, few problem with the audio here. So now, if can I share slides?
Yeah, I'm not allowed to share my slides.
So can I be allowed for sharing a few slides so that I can answer?
You should be able to do so in a moment, Marina.
Yep, thank you very much. Can
you share now?
Check it. I don't have yet.
I can share my slide.
Okay, now I can. Yeah. Okay. Okay, so after this, so thank you all the speakers for their presentation and their contribution to this discussion, and also to all of you for your questions. Okay. So, as following on what has been presented, I'm now introducing you how we are planning to carry on with the beta testing of EDITO infra platform. So the roadmap is in a different phase. we had the first beta testing phase, that is the one that has been involved in this workshop today. That started last September, and it was mainly involving the specific community of EDITO Model Lab, as already said, because by project they have to use the platform, plus additional beta tester, as we have seen, for example, with the presentation of Matteo. Then we are planning now a second beta testing phase for you. And so we are opening the platform for so that you can register, and this will allow you to beta test the platform right before and after the DOF event, and it's just restricted to you. We are launching a wider phase of testing that will start in September 2024, and we will provide information soon. But now, so providing details for this phase, that is the second phase, that is the one that is impacting on you. So it's open only to you, so only to the 70 invited project to the event, so the scientific and technical workshop that is organized for June 12th for the DOF 2024. And there are 3 milestones. So the first one is now, where we have provided you a quick demo of the platform. Then there is the second milestone that will be the scientific and technical workshop that we will have in Brussels. And then we are organizing a follow-up webinar that we are targeting the last week of June, with a date and time to be confirmed, for collecting and discussing your feedback. And so in this phase, the main objective is to test with you the discovery access and the basic usage of the EDITO platform. So you will be allowed to explore and create, and you will be able to register in the platform only in the next 24 hours. And here you have the link. So the link is the one that I already provided also in the chat. And through this beta testing, so what are the rules for beta testing in the second phase? So you will be able to support with the discovery of the platform functionalities and all the available services. And our team will invite you to a support channel where you can ask questions and get answers. Then be aware that so EDITO Infra platform is not an operational service yet, and so your access to the platform as beta tester could be temporarily stopped without any warning for any technical or other issue that require this. And also the support channel is limited and only during working hours. And so please be aware of this limitation link to the pre-operational phase of EDITO platform. And I hope that this will give you the opportunity to understand better what EDITO Infra is, and to provide the feedback that we need for improving what has been developed and for developing it further. So we really count on your support for this testing phase. And I think that we can close.
Marina,
so,
do you mind if I just say something quickly?
Sure.
Yeah, just to make sure that people understand that the EDITO platform does not replace the existing eModNet or Copernicus Marine services. It's a complementary data processing platform. So all our services are for eModNet, for example. When you go to the eModNet portal, all our data services will continue to be there, but we make copies of those data products in the EDITO platform to help people do better data processing. So I just bring it up here because it gets asked a lot of us. It's an expanded service that we're offering users. That's me, Marina.
Yep, so thank you, Connor. So Julia?
Marina, yeah, if you want, I can also pick up the question that was more specific about the scientific and technical workshop and what to expect. So just to say that we really look forward to seeing you in person in Brussels on June 12th. We were really looking forward to this webinar as an opportunity to make sure that the community of projects that will be involved in the workshop had an opportunity to look into the EDITO platform and to play with it ahead of the workshop. So we really hope that all the presentations that you heard today will have been useful towards that purpose. But then the idea is that, of course, you have at least a couple of weeks to digest all of these contents so that we can have a more informed conversation in Brussels. So the workshop has been set up as a hands-on event. It's half day. It will kickstart at noon with a networking lunch that will kick off formally at 1:30, and it will go on up until 6 p.m. We will have an opportunity to, again, revisit the capabilities of the platform through the eyes of users, as you've done today, but also to then break out in 3 different sessions so that you can also have an opportunity to dive in deeper into those aspects of EDITO that might interest you more or come closer to your area of interest and expertise. So we'll be having a conversation about EDITO Data Lake and the modeling engine, and bringing contributions from the community as to how do you see that evolving in the future. We'll also be having a second breakout session looking deeper into interoperability. So we have colleagues from different projects and initiatives that will be sharing the work that they are doing on different digital twins or digital twinning initiatives and applications. And then we'll also have another breakout session to look more towards the long-term vision and the future in terms of how to shape up a fit-for-purpose DTO that can respond to policy objectives. So again, just a really great opportunity to come together and to have a constructive discussion from the community to see how we continue to drive things forward towards shaping the European Digital Twin Ocean. So very much looking forward to seeing you in Brussels, hopefully as well. And that's all I wanted to share, Marina.
Thank you, Julia. And I hope that you are now all waiting for the DOF event. And so we are really waiting for seeing you and meeting you there. And as I said, so we count on your collaboration and your contribution. And I think that so we can conclude this 1 hour. We are already almost 10 minutes delay, but I think that it's fine. And so thank you very much for your time and for your contribution, and looking forward for meeting you soon in Brussels.